In this example, we're going to talk about Newton's second law and ramps, when boxes are on ramps. Some of the things to remember: when we place the box on a ramp, we often have the normal force. Remember that the normal force has to point out of the ramp so that it's perpendicular to the hill. And then we have the force of gravity. For this first example, let's make it frictionless. Okay, just to make life a little bit easier. Let's say that the mass of the box is 8 kilograms. The angle of the hill is 25 degrees. And let's find the acceleration of the box as it goes down the hill. Remember that when you have the object on a hill like this, that you form your triangle by coming down parallel or straight off of the normal force, turning it 90 degrees from that, and making your triangle there with the force of gravity, so that this angle up there is theta again. So that over here on this side you have Fg cosine of the angle, and this side going down the hill is Fg sine theta. Because if it's frictionless, the box is going to accelerate down the hill this direction. Let's make that positive. From this diagram, it's fairly straightforward, I think, to see that Fn is balanced with Fg cosine theta. So we could find, from that information, we can find the value of the normal force. This would be 80 newtons times the cosine of 25 gives me 72.5. I got 80 again because 8 kilograms would give you 80 newtons. 72.5 newtons for all of this. That means that this side, this portion of the force of gravity is 72.5, and it's balanced by the normal force, which would also be 72.5. So those two values are equal. Now going down the hill, I don't have any friction to balance anything out. So I've got this Fg sine theta, net force equals mass times acceleration. Going down the hill this way, all I've got is, going parallel to the hill, all I've got is Fg sine theta. So Fg sine theta will equal m times a. I'm solving for acceleration. So 80 newtons times the sine of 25 will equal the mass of the box, 8 kilograms, times the acceleration. So 80 sine 25, 33.81 newtons equals 8 kilograms times acceleration. Divide by 8. And acceleration is 4.23 meters per second squared. So as the box slides down the hill, assuming it's truly frictionless, it's going to pick up speed at this rate, 4.23 meters per second for each second that it's able to slide down the hill. In the case of there being friction, so let's draw another example here. There's the angle. Here's the box. Okay. If I include friction in this whole situation, let's say that mass equals this time 7.5 kilograms, and friction equals, let me do a little bit of checking here. I should have made numbers up before I started. Let's give the angle, it's 21 degrees. So friction, let's say, is 12 newtons. So as the box slides down the hill, we'll just make up a number and say that friction is equal to 12 newtons. The angle is 21, the mass is 7.5. So drawing the force diagram again, we would have the normal force here, we would have gravity here, and this time we would have friction going opposite. Again, as the box slides down the hill, if it accelerates, it'll accelerate down the hill. Draw my triangle on gravity. This is Fg cosine theta. This is Fg sine theta. Again, Fg cosine theta and normal force will be balanced, so they'll just be equal. I don't really need that number right now, so I'm not going to finish solving for it. Up and down the hill, so starting here I go down and then down, so Fg sine theta goes down the hill, and friction goes up the hill. If this is positive, then this is positive and friction is negative, is how I got all these numbers here. So Fg sine theta is going to be 75 newtons times the sine of 21 degrees minus the friction, which is 12 newtons, has got to equal mass times the acceleration. We see that it's not going to be accelerating quite as much because I've got to take 12 newtons off due to the friction before we ever get going. So 75 sine 21. This gives me 26.88 newtons minus 12 newtons. So subtracting here, I get 14.88 newtons has to equal 7.5 kilograms times acceleration, divide by 7.5. And I get that the acceleration in this case, for this example, is 1.98 down the hill. So as the box slides down the hill, its acceleration is 1.98. Very similar sorts of problems to other problems that we've already worked. It doesn't really matter which way you turn the hill. The equations come out looking, right, with friction come out looking very similar to these, and without friction come out looking very similar to these, here and here. And that's how you solve Newton's second law problems, where the object is placed on a ramp.